So in this video, we're going to look at converting between degrees and radians. So far in right triangles, you started working with all degree measurements. That's what you're most comfortable with. You know approximately what a degree is. However, now we're going to start looking at radians because they actually make a lot more sense and they're smaller numbers to work with, or at least easier numbers to work with in terms of trying to get through application pieces, because we're going to start graphing these down the road. We're going to start looking at circles. We're not just going to look at triangles anymore. So to begin with, if I were to draw a circle, how many degrees are in that circle? 360 degrees. So I could draw in all of these radii, and every one of those marks is a degree. And I should have 360 of them to go around the circle. How many degrees are in a straight line? 180. It's really just a semicircle. Okay, so those are the pieces that you know already. We're going to get out of this degree piece, and we're going to move into our radian part. Now, in order to do this, I'm going to look at the fact that this radius is going to be 1. We're going to actually look at what's called a unit circle. We'll get into more of that in a couple of days. But that radius length is 1. So when I start talking about, okay, what's my physical measurement here, I can talk about it being a degree, 2 degrees, 3 degrees, etc. Now, that measurement, that's length 1. I'm going to draw myself a nice circle. So there's my radius of 1. Now what I can do is I can take a measurement with this. So I'm going to take this length, and I'm going to go around the outside of my circle. So I'm going to start with this one. Bear in mind, it may make straight lines on me. That's approximately to there. And then I'm going to do it again, which we get to about maybe here. Again, I apologize for the straight line. Here. It does actually measure along the arc. And then there's that little piece left over there. What I created here, this length and this length are the same. This angle is 1 radian. 1 radian is made up of its radius to arc relationship. And if you notice, there are 6 full radians going all the way around my circle. And then there's this part, which is 0.28 of a radian. Okay. That's a full circle. Now, let's think of this as a semicircle. So I'm going to cut this in half. So 6.28 was for my full circle. There's that many radians going around, which means there's that many radians inside. For a semicircle, it's half of that, which is 3.14. Now, I told you already that our radius is 1. So with our radius being 1 here, I could find the length, my circumference. Remember, circumference is 2 pi r. My radius is 1, so my circumference is 2 pi. For my semicircle, I'm just going to do the arc around because I'm just looking at my angle measurement. The circumference for the semicircle is half of that, which is pi. So, for a full circle, there are 6.28 of these radians around the inside. In a semicircle, there are 3.14. 3.14 look familiar at all to you? That's pi. 6.28 look familiar at all? That's 2 pi. Radians work out nice in terms of pi. We're used to the circumference of a circle. Okay, the circumference of a circle has always been 2 pi r. My radius is 1, therefore it's 2 pi, because a radian is just that arc measurement. It's the radius to arc relationship. So, Degrees, kind of random. Can you approximate what 1 degree is? Sorry about that. Is this a degree? Is this a degree? I'm going to say no, because halfway across is 45 degrees. I have to have 45 tick marks in there. A radian, that's not so bad. And when I look at this, I'm going to get exact values. Please keep in mind, initially, you might struggle a little bit with radian measurements just because you're not familiar with them, and they do start to bring in fractions. Fairly common fractions, but they do bring in fractions. But you've been ingrained in your head over and over, 360 degrees, 180 degrees. You know those degree measures. Not quite as much the radian measures. So we're going to start by doing some conversions to kind of help you start to feel comfortable with that. So if I start with a degree measure, what I have to do is take that degree measure and multiply it by pi over 180 degrees. Degrees have to have a symbol, radians do not. If I do this, I'm getting rid of my degrees, because really this is like degrees over 1. The degrees on top and bottom will cancel. My radians will be left on top, so outcome is my radian value. However, if I start with my radians, for radians, I need to get rid of my pi, because pi is my radian measurements. So therefore, it's 180 degrees over pi, which therefore will give out my degree measurements. So it's just a quick little form of 1 that you're going to be multiplying by to get rid of, or to move from radians to degrees or from degrees to radians. A nice little graphic to help you remember, if you start with degrees and you need to get down here to radians, you just multiply by pi over 180 because you want to get rid of your 180 degrees. To go from radians into degrees, you are going to be multiplying by 180 degrees over pi because now I want to get rid of my radians. So just a nice way to kind of help you with it. So we are going to convert 2 examples. One of them is in degrees. We're going to convert it to radians. One of them is radians. We're going to convert it to degrees. When you have radians, you don't want to get rid of your pi. You want pi in there unless you can't or it doesn't make sense to. Pi keeps your values exact. So here I have 45 degrees. If I want to convert it to radians, I take 45 degrees. Converting it to radians means I'm bringing in pi and I'm getting rid of 180 degrees. Okay. So, and then I can multiply straight across, top and bottom. I could think of simplifying as well along the way. 45 goes into 45 once, 45 goes into 184 times. 1 times pi is pi, and across the bottom, 1 times 4 is 4. So it's pi over 4 radians. No label is necessary because it's radians. Then I want to convert 3 pi over 4 into degrees. So I take that 3 pi over 4, I multiply it by my degrees, because I need degrees in it. I get rid of my pi. Now, please simplify ahead of time. Think about this. Don't take 3 times 180 and try to divide it by 4. First off, pi's are gone. Pi on the top, pi on the bottom, gone. And then I'm going to simplify the 4 and 180. Now, if you don't know 4 goes into 180, I know at least 2 goes in there. That goes in there 90 times, and then 2 goes into 2 once, and there 45 times. Maybe you saw it right away, that's fine. But breaking those down without having to actually multiply all the way across is great. Now multiply straight across. Therefore, 3 times 45 is 135 degrees. And then 1 on the bottom, so my answer is 135 degrees. So as you start working through, if I give you a radian measurement and you're not super comfortable with it, feel free to convert it, or vice versa. We get into some equations that are much easier in radian mode. But you are going to have to learn how to work in radians. We're going to do a ton of graphing trig functions in radian mode, so you have to start feeling comfortable with working with these fractions and having pi in your answers. Now, with degree measures and radian measures, we started introducing this unit circle, and we're going to keep going with this for just a little bit. When I measure angles, it's always on the x-axis in the positive side. That's where I'm always going to measure them from. That's my initial ray for my angles. So it's always going to start that way. So for instance, here is my angle. We'll call it a 60-degree angle. It is a 60-degree angle because it starts from my x-axis and goes counterclockwise. Positive angle measurements go counterclockwise. Positive angles go counterclockwise. Versus negative angles, I still start at the same spot always, but they go clockwise. So this angle here, for instance, would be negative, let's say that's negative 50 degrees. Because it's starting on the positive side of your x-axis and it's going clockwise. Clockwise angles are always negative. Counterclockwise are positive. Kind of sounds backwards, but that's the way we go. Specific to, if you remember quadrants, first, second, third, fourth, it goes in the direction of quadrants. Now, I could give you a negative angle. For instance, or maybe let's say a positive angle to start with. So I give you this with, let's say, it's 330 degrees. Not quite 360, it doesn't quite get back to that starting line. Now I could also say it ends at this spot, and this angle is negative 30 degrees. They are not the same angle. They just end at the same spot, and we're going to talk about that in our next video. But please don't get that confused. We have positive angles, we have negative angles. Sometimes they land on the same spot, but they are not the same angle. Very, very different. I can keep going multiple times around my circle. Let's do a couple more of these. It's not just once around I can go. So let's say this is my arc. However, I'm going around one full time around my unit circle, and then an additional 65 degrees. So maybe this arc here is 65 degrees. So I have to take into consideration, I've already gone one entire cycle around, which is how many degrees? 360 degrees, plus this additional 65 degrees. So this would be 425 degrees. So please feel free to keep going around the unit circle. I can keep going an infinite number of times because, again, we're going to graph these. We're going to go in the positive direction. We're going to go more than just 360 or 2 pi out. We're going to go in the negative direction. We're going to keep looking at where our distances are in relationship to our time. Also, you can go negatively an infinite number of times. And then lastly, we can do these in radian measurements. I can look at having an angle measurement here of pi over 3. If you don't know what pi over 3 is yet, go ahead and convert it. You can get about what that approximation is so that you can see what it is. But I can go an entire unit circle around as well. So I can go all the way around, and that would be 2 pi plus pi over 3. So adding these together, I'd have to have common denominators. So 6 pi over 3 plus pi over 3. This angle measurement is 7 pi over 3. You are going to want to stick with those radian measures, but just to make sure that you're doing things correctly, that things are landing in the right spots, you may want to convert them to degrees just to have a quick check. So make sure you can go positively, you can go negatively, and you can do your degree to radian conversions.